Hello, and welcome back to G Fun Facts Online, the show that beams amazing facts directly into your brain. Today, we're looking up, way up, into space to uncover a truly electrifying topic: space-based solar power. Imagine limitless clean energy beamed down from orbit 24/7. Sounds like science fiction, right? Well, it's rapidly becoming science fact, and the race is on. So, what exactly is space-based solar power, or SBSP as the cool kids call it? Think big. We're talking about gigantic solar panels, potentially kilometers wide, orbiting Earth. Up there, the sun never sets, there are no cloudy days, and the sunlight is way more intense than down here. These orbital giants would soak up that powerful solar energy. Step 2. This energy gets converted into electricity right there on the satellite. And here's the truly mind-bending part. Step 3. That electricity is transformed into microwaves or lasers and beamed wirelessly down to special receiving stations on Earth. Yes, wirelessly, like superpowered Wi-Fi for the entire planet. Now you might be thinking, this sounds incredible, but is it really happening? Absolutely. And 2024 has already been a landmark year. Just this April, UK-based Space Solar successfully tested their Harrier 360-degree wireless power transmission. Imagine a satellite that can beam power in any direction without even moving. That's a game changer for keeping aimed at both the Sun and Earth. This is a core piece of their awesome Cassiopeia solar power satellite concept. And get this, Caltech's Space Solar Power Demonstrator mission just wrapped up in January, and for the first time ever, they successfully collected solar power in space and transmitted detectable amounts to Earth. One of their key gadgets was called MAPLE, the Microwave Array for Power Transfer Low-Orbit Experiment. Even the European Space Agency, through its Solaris initiative, recently showed off microwave beaming in Germany, powering a model city and even making green hydrogen from 36 meters away. It's not just about beaming, though. Scientists are developing hyper-efficient, lightweight solar cells that can survive the harshness of space, extreme radiation, and wild temperature swings. Companies like the University of Toledo are working with the Air Force Research Lab on these very thin film materials. And how do you build these colossal structures in orbit? Robots, of course. Think autonomous construction crews, like GT Inchworm robot, designed to work in high radiation zones, assembling these mega satellites. Plus, thanks to reusable rockets like SpaceX's Starship, the cost of getting all this gear into space is dropping dramatically, making these sky-high ambitions more down-to-earth financially. This isn't just a dream of a few scientists. It's a global pursuit. Japan is aiming to launch a demo satellite, the OHISAMA project, as early as 2025 to beam power down. China has massive plans for a test station by 2030 and a gigawatt-scale system by 2050. The USA, with NASA and the Air Force Research Laboratory, is deeply involved, studying feasibility and even planning to beam energy to Earth with projects like Arachne. Europe's Solaris initiative is pushing for a decision on a full development program by late 2025. And the UK wants an operational system feeding their grid by 2040. Now let's be real, this is a monumental undertaking. The initial costs are still sky-high, even with cheaper launches. Getting that wireless power transmission super efficient is a major research challenge. We're talking about improving from around 10 to 15% in experiments to a theoretical 50 to 80%. These structures are massive, both in space and the receiving stations on Earth, which could cover huge areas. Assembling and maintaining them in orbit is an engineering marvel waiting to happen. And of course, we need to ensure it's all safe for humans, animals, aircraft, and existing satellites, and that we're not adding too much to the space debris problem. But the potential rewards? Oh, they're dazzling. Imagine continuous, 24/7 baseload power, unaffected by weather or night. Sunlight in space is more intense, meaning more bang for your buck. We could beam power to remote disaster-stricken areas, or even future moon bases and Mars colonies. And while the receiving stations are big, it could potentially reduce the overall land needed for renewable energy. This is more than just power. It's a pathway to a cleaner, more sustainable future, So, space-based solar power, a giant leap for energy kind. It's complex, it's ambitious, but the ingenuity on display is truly out of this world. What do you think? Is this the future of energy? Let us know your thoughts. Thanks for tuning in to G Fun Facts Online. Join us next time for more amazing facts.